So welcome to all of you. Today we will discuss the implementation of lasso and elastic net regression by using Python programming.
Now let us discuss about the lasso regression. So let me show you the equation of lasso, the lasso regression equation of loss. So here basically this is a value of loss function with respect to lasso regression. Here we are having an additional term that is known as L1 penalty, right? So if you increase this lambda, so slope is getting down. That is the actually idea behind the regularization. So basically, if you have a high dimension data, then there is a likely chance of overfitting, right? So to handle this, we use lasso regression. So basically what it does, it checks the unimportant features, and all those unimportant features coefficient, it will make to 0. So as a result, we are doing a feature selection, and as a outcome of that, the dimension of data frame is also getting reduced. So basically we use lasso regression over the ridge in case of high dimension data. So with this understanding, let us implement the idea of this lasso regression. So here these are the essential libraries which we are having, and that we have imported. Now here see the same data set which I am using from very long, the same data set I have created over here. So this is how my data set is looking like. What we did, simply we have applied over here the simple linear regression, that is OLS model, right? So with that, it is returning the m value as a 27.93, and this is my intercept value, right? So with this idea, let us see how well this lasso regression will perform, how lasso regression will give you the value of m and b. So what we did here, different value of alpha we took, and on that I am calculating this, we have to calculate the value of m and b. So those values I have plotted. So let us see this image. So now see, this is the model with respect to lambda is equal to 0, that I am representing by this blue line that is somewhere over here. So if you recall, the idea behind to reduce the overfitting is we have to reduce the slope, right, that we have seen with the example of ridge, right? So basically the coefficient value is getting reduced, right? So here the same thing has happened. If I am increasing the value of alpha, that is nothing but the lambda, further the m value is getting changed, right? This m value has changed, it is reduced. Similarly, if you increase the alpha, gradually the m value has further changed, and if you increase this alpha is equal to 30, this m value will become a 0, right? So that is actual difference between ridge and lasso. If you recall, in ridge regression, even you are increasing lambda to at a certain high value, even though the coefficient value was not becoming 0. Whereas here in case of lasso, if you increase lambda, the slope value is becoming 0, which simply means that here the unimportant, it is going to be remove the unimportant features from the data set. So basically we are doing a feature selection. We are going to be choose only those features which is having a important influence over the outcome. So that is somewhere this lasso is useful over the ridge regression. Okay, so here what we did, we have created our own data, and what I did over here, this is a polynomial 16 I took, and over the different value of alpha we are plotting this model, right, polynomial linear regression model. See here, at the alpha is equal to 0 means at simple polynomial linear regression model, this is the represented by this red line, right? So it is having a little bit of overfitting. when I have increased this alpha, when I put this alpha is equal to 0.1 to this lasso regression, by using lasso regression, see it is represented by this green line. So this green line is, it is a kind of balance, no? I mean, it is optimally fit the data. Whereas if you increase alpha too much, now this is represented by this blue line, it simply shows the underfitting, right? There is an underfitted model. So again, the tuning of alpha is important. That's why lambda is here again the hyperparameter. Okay, so if you increase alpha, so what is the conclusion over here? So if I will include, if you increase alpha, the coefficient term may become a 0, right? So that's why we use this concept for doing a feature selection. Okay, so with this idea, let's move further. Let us conclude this. What is the takeaway point from this lasso regression? So the first concern is, my bad. Okay, so first concern is how coefficient is affected with the with this lasso regression. So again, the same data set which we have used in this regression that I have chosen over here, and I have loaded. See, this is the value, right? This is the how our data frame is look like. Okay, so once I train this through the lasso regression, so here at the different value of alpha, I am training this, and I am plotting the R2 score with respect to this. Let me show you this, what actually it is returning. So now see here, what is happening if I am increasing, okay, so if alpha is equal to 0, it simply means it is a kind of OLS model, right? So here you must see these are the value of coefficient, and the R2 score corresponding to OLS is 0.44. Okay, so if you increase the alpha value as a 0.1, then this R2 score is becoming 0.43. Now important part is the number of coefficient. See, initially in OLS, number of coefficient were there, but if you increase this alpha, see, number of coefficient has disappeared, right? And the value of that was also changed. See here, range was minus 750 to plus 750. Now after increasing this alpha, the range has drastically changed. It is from minus 100 to 500, and number of coefficient values was also changed. Now if you increase further this alpha value, further this R2 score has changed. What is the important part here? Here initially we were having a number of feature, but after increasing this alpha value, I am getting only the prominent feature as outcome. That's why this lasso we use for the feature selection. If you increase alpha too much, all this coefficient value will disappear. So that's why this concept basically we choose for the, in a case of higher dimension, right, for choosing the important and influential feature, right? In that case, lasso regression we use over the ridge regression. So basically lasso and elastic net both are important one for doing a feature selection. Okay, so the second question comes, what is the, higher coefficient are affected more? That is the conclusion, right? So basically if you see here, the value, see, the S2 was this was the S2 coefficient, and the value of that one is around 500, right? After applying this lasso, the S2 term was completely disappear. Whereas the S5, the value was around 750, right? 0 to 750. After doing this lasso regression, after applying this lasso regression, the value of S5 is ranging from 0 to 500 only. Again, it has reduced, right? It has reduced. So if you recall, that was the idea. We have to reduce the coefficient value. By that way only we can handle the overfitting problem, right? So you will see here directly with applying lasso regression, we are decreasing the coefficient value. Similarly, if you further decrease it, see what was the BMI value? See, this was a BMI value from ranging up to 500, right? After applying lasso, this BMI value was changed. It was same like up to 500. But if you increase this alpha further, now this BMI has changed up to 350. Now, this graph, only the prominent features we are having. Remaining features this lasso regression has made it as a 0. It make it as a 0, right? That is the idea. Okay, so what I want to say is the higher coefficient values was affected more. So what I did here, I have given the different alpha values, and as per that I have applied the lasso regression on each alpha to show you how much coefficients are influencing by this lambda value, this alpha value. So in this table you may see here, with the alpha, this coefficient values are also changing. So initially when alpha is equal to 0, this is nothing but the OLS, this is a coefficient value, right? But if you apply this lasso regression at lambda is equal to 0.0001, then see many values are getting down. See here, maybe in this case it is almost same. But if I increase the alpha value in third iteration over here, see here, these coefficients are getting reduced, right? And subsequently, if you see the further steps, now at this alpha value, see this age coefficient value will become 0, whereas this S2 coefficient with respect to S2 has also becoming 0. Same thing is true with the S4, right? Now if you further increase this alpha value, many of these features coefficients are becoming 0. Now these are the remaining features, I mean they are the most influencing features which I can use for doing a further predictions, right? Which can I use for my model building, right? That is the idea. That is the idea behind this lasso. So basically this is used for doing a feature selection, right? Now at the different values of alpha, let's calculate the coefficient value, right, by applying this lasso regression. So I have trained it. Now you may see here what is happening. So with the, now see these are the coefficient value. Now if you train it, see what is happening. The higher coefficient value is getting down in the fastest way. So this yellow was the S5 value, right? This was a higher coefficient value. It is getting down very fast. Similarly, this green values with respect to BMI, that coefficient value is also getting down, right? Similarly, all these coefficient values are getting down. After certain level, after certain lambda, this all coefficients values are becoming 0. So we have to find out this optimal one, right? So that is that's why it is a lambda is a hyperparameter, right? So that we have to select properly. Now the another concern is this bias and variance trade-off, right? How this influence the bias and variance. Let me show you first. So this bias and variance is having this kind of relationship, right? So if you increase this lambda, so basically this this value of bias is actually increasing, but with that variance value is getting reduced, right? So that is a plot between bias and variance, and this bias and variance are inversely proportional to each other. We have to find out lambda value somewhere over here, right? So that is something which we have to find out. So that is an ideal case. Now in my case, what has happened, I have created one data, and the same thing, I have applied this polynomial feature at the degree 10, and with the different values of lambda, I'm calculating it, the lasso regression. Now see, as the outcome what I am getting, see this is the outcome of that. So here what is happening, with the increasing value of lambda, this bias value is increasing, but there should be substantial decrease in this variance, but it is kind of constant over here. So maybe it is a data dependent, but actually ideally this kind of relationship should this bias and variance should have, right? So in my case, maybe this is a value which I am getting. Okay. Now the another important regularization technique is known as elastic net. So basically elastic net is a amalgamation. It is a combination of ridge and lasso, where the penalty is calculated as a combination of penalty term used in ridge and lasso. So that is the important thing. So basically we use this elastic net when the large number of parameters are there with a large volume of data. So in such case there will be chance of useless data to make any predictions, right? So those useless data we have to make it as a 0. So basically lasso and elastic net both we use for doing a feature selection, right? But on contrary, what is the advantage? When we use this lasso regression, it will go through all the column in the data set and finally uses only those columns which is having a highest influence on the outcome. So basically we were choosing a most important influential features, right? Whereas if you talk about the elastic net regression, it will internally use a loop through all the column and determine the output. It understood which column is influencing the output more, but it will not use only a single column. It is going to use all the column. Hence, this elastic net result is better than the lasso regression, right? So that is a somewhat intuition behind this elastic net. Okay, so what we did over here, the same sort of data set we have imported, x and y we have separated over here. Now applying this trend test split, simply I have applied the linear regression on that, right? I have made the object of that, then I have trained my data. The R2 score was 43.99, right, with a simple linear regression. When I have chosen this ridge regression, now you may see at the alpha is equal to 0.1, now accuracy of my model has improved, right? In OLS it was only 43.99, whereas by using ridge it is becoming the 45.19, right? Whereas in case of lasso, again alpha value we have given as 0.01 and then lasso the value is becoming 0.44, right? Whereas we use this elastic net in the case of, as I told, in a high dimension data. So in a high dimension data there is a one more probability of multicollinearity. So there may be chance that many features they are not independent from each other. Some of them are depending on each other, right? So that effect is known as a multicollinearity, right? So such kind of situation, when we were having a multicollinearity, we use this elastic net over the region lasso. So that is the idea, somewhere we have to use this elastic net. So in elastic net, what we have given, so this method is already there in sklearn. Here we have to pass this two parameter, alpha and L1 ratio. In my case, I have taken alpha, that is nothing but lambda is equal to 0.05. and L1 ratio is 0.9. It simply means 90% of ridge I am applying and 10% of lasso. Because as I told you, elastic net is a combination of ridge and lasso, right? So basically penalty term is calculated as a combination of penalty term used in both ridge and lasso, right? That is the idea. So with this concept, I have given this parameter, and ultimately if you see the score of this one by applying the elastic net, we are getting at a 45.31. So you may directly compare this. So this is giving a better result from lasso, right? And if I am not wrong, this result is better than ridge also. See, that was a 45.19. Here it is a 45.31. And this elastic net, as I told you, because it is a combination of that, it is using all the columns. It is using all the columns internally, right? So that's why this elastic net always gives you the better result than ridge and lasso.
So basically, let me summarize the point which we have learned so far. The idea behind this regularization is we have to minimize the variance without substantial increase in the bias, right? So based on this concept only, we used, if you include this regularization term into the equation of line, so basically we used to get the three variation, right? One is the ridge, another one is the lasso, and the third one is the elastic net. So this regularization is a technique to minimize the variance without much increase in the bias. So we can do this regularization in the model by using this ridge, lasso or elastic net. So the formula used by lasso regression is basically equation of the line plus sum of squared residual plus lambda multiplied by absolute slope, right? So this lasso regression has a L1 penalty term. So this L1 indicate lambda multiplied by absolute value of slope, whereas ridge regression considered all the column in the data set to predict the final output, whereas in the case of lasso regression, basically select only one column that bear the highest influence on the final result. So generally we use this lasso regression for the feature selection. So Another point is this regularization is the formula basically which we use for doing this elastic net regression, that is the equation of the line plus sum of square residual plus lambda multiplied by absolute of slope plus lambda 2 multiplied by slope square. So here basically this lambda 1 indicate the penalty of for lasso, lambda 2 indicate the penalty for the ridge. So this term absolute of slope is called L1 penalty term, and lambda 2 multiplied by slope square is called L2 penalty term. Here this lambda 1 and lambda 2 should be greater than 0. Then it will be the elastic net regression. Both lasso and elastic net regression basically useful for doing the feature selection. Thank you.